Welcome to part 5 of this Dave on Data tutorial series, a Python crash course. The topic of this video is Python lists. Python lists are a fundamental data structure. You use lists all the time when writing Python code for analytics and data science. Therefore, learning Python lists is a necessary step in your journey. As always, please follow along with this video by typing the code that I type. Don't hesitate to pause or rewind the video if needed. You learn Python by writing Python. Here's the myOrders data table again for reference. Consider the order amount column above, this column right here. What we can see here is that this is a collection of values. While the values shown here appear in ascending order, that is purely coincidental. Typically, column values are not ordered. It is also typical that column values can have duplicates. So for example, imagine if this table had thousands of orders in it. It's very likely that more than one order would have an order amount of $9.99. So what we can see here is that there's a lot going on with this collection of values. There's 3 individual values. They're not in any particular order, but I can reference them by whether this is the first value, the second value, or the third value. I can even provide a name for a collection of values. For example, here we have order amount represents this collection of values. So when you keep all of this in mind, we can think of a column as being just an arbitrary collection. In Python, the data structure that has these characteristics is known as a list. A Python list is an arbitrary collection of values, or more specifically in Python, an arbitrary collection of objects. So you can see here that I'm in a brand new Jupyter notebook. If you need instructions on how to create a Jupyter notebook from scratch, see part 4 of this tutorial series. So what I'm going to do here is create a Jupyter notebook that I'm going to be using for the next several videos, because all of the videos are going to be around data structures. So what I'm going to do is name this notebook, rename it to data structures. And how I did that was I just clicked up here, and then I got the rename dialog, and I renamed it. And you can see here now my Jupyter notebook is called data structures. And I'm going to add some cells here. I'm in blue mode, so I can do get a bunch of cells, scroll back up. And what I'm going to do is change this very first cell to markdown. And I'm going to go ahead and put in my main heading here, data structures, Control Enter. And then I'm going to change this next one to markdown as well. And I'm going to make this hashtag lists, because what I will do is add things like dictionaries and so on and so forth to this notebook over time. Okay, so let's talk about lists. Lists are arbitrary collections of objects. So let's make that explicit in a comment. Lists are arbitrary collections of objects. So we can create a variable. We've seen this in the previous video, and I'm going to call it my list. Okay, this is going to store an object of type list. And how you define a list in Python is you use square brackets. Notice that as soon as I hit the open square bracket, the left square bracket, Jupyter Notebook automatically fills in the subsequent square bracket, because that's a very common thing that you do in Python. And we can put in a collection of objects in my list. So for example, I can put in the integer 1, I can put in the float value 2.0, I can put in a string, let's say hello, and then I can put in another string called world, and it's an arbitrary list of things, an arbitrary list of objects, and they don't have to be all the same kind. A list is a generic structure that just holds a collection of objects of any kind, floats, ints, data tables, strings, whatever it might be. I can run this, and not surprisingly, I get an error because I forgot something. I forgot my assignment operator. So if I run this, when the code's written correctly, you get nothing back, because I instantiate a new list object and assign that object to the variable name my_list, but it doesn't actually do anything. So what I can do is I can print it out so I can see what's actually in my list. So I can print it out. I can also ask for the type of my object here, and it comes back list. So what we have here is a list. It's a collection of stuff. Now here's the thing. Because it's an arbitrary collection of objects, you can have duplicates. That is 100% legal. So let's go ahead and see that in action. So lists can have duplicates. And I'm going to go ahead and overload my list. I'm going to replace the existing one with a brand new object, because if I have two variables with the same name, the last cell that is run in my notebook wins. So this will be a new version of my list. And I can do, let's do something silly. 1, 1, 2, 2. And then of course I can print my list. And you can see I've got the duplicates, and that's no problem. Now there's some other things that I can do with my lists as well. You can actually ask stuff about lists. For example, you can say, what's the length of the list? How many items, how many objects are in the list? And how we do that is we use a new function that we haven't seen before called len for length, L-E-N, my list. And let's take a look at what's going on here. So we're starting to see nested code here. And if you're familiar with programming languages or even using formulas in spreadsheet software like Microsoft Excel, you're used to this. But assuming that you're not, let's talk about what's going on here. Essentially, the way you can think about code is that Python code, as well as any other type of code, is that it kind of works from the inside out. So this is the innermost thing that's going on here. I'm calling the len function on the mylist object. And what that does is that returns back a numeric value, an integer that tells you how many items are in the list. It's a counting number. So I should get back the number 4, right? Because we have 1, 2, 3, 4 items in the list. And then that 4 is then passed into the print function here. And the print function then spits out the value. So once again, if I just run this code, I get back 4. So that's some cool things that we can do with lists, but there's more. There's more. Now I said that you can put basically any type of object inside of a list. So here's something that you're going to see very commonly in analytics and data science work with Python. Lists that contain other lists. So this is actually really super common, for example, in doing text analytics with Python. So I'm going to overwrite my list again, and I'm creating my outer list, right? I've got my outer square bracket. And then I can put whatever I want inside of it. So I can put in 2 lists. See what I'm doing here? I've got 2 lists. Lists within lists. Okay, and then I can say, hey, I'll put 1, 1, 2, 2 here. And then over here, what I'll do is I'm actually just going to scroll up and then just copy this right here. So I'm going to highlight it, copy, and then paste it down here so I don't have to type it all over again. And voila, I have a list of lists. Now, what we can do here is interesting things. We can say, hey, go ahead, let's print my list here. And let's go ahead and print the length, the len of my list, and see what we get. And we get what we would expect, right? So this shows clearly that I have this list is inside of the list, and this list is also inside of the list. And when I ask for the length of the my_list object, it returns 2, because there are 2 items, there are 2 objects in the list. They happen to be lists themselves, which makes things a little bit more complicated. But in theory, there's only 2 things in my list. So moving on, you can create empty lists. It's a legitimate list object to have nothing in it. You can think of it as like a jar, a container. You don't have to have something in a jar to have a jar. Same idea. So we can say lists can be empty. I'm going to go ahead and scroll up here a little bit. And here's how you do it. All you do is just use square bracket, square bracket. This is a empty list. It's a legit object. I can use my list in code. I can say, hey, print my list. And I can even ask for the length of my list. This is all legit. And you run that and you see, of course, I get a empty back and 0 because there's nothing in there. And this is something that's quite handy to do, because what you might often do is create an empty list object and then add stuff to it. So this is, for example, something that's very commonly done in text analytics once again, but all kinds of other types of scenarios as well. So let's talk about how you add stuff to a list. So lists are mutable. Okay, this is a fancy word right here, mutable. All this means is that you can change a list. So in Python, there are, and as with other types of programming languages, there are essentially 2 types of objects. There are objects that you can change, which can be mutated or are mutable, and those that cannot. All you can do is replace them. You have to create a brand new object and replace the existing object because they're cast in stone. They can never be changed. Lists are mutable, so you can add data to them. And how you do that is you use a method, a function, a behavior that belongs to the list class, the list object. because there is a class called list, by the way. So there's list right there. Just like we saw in the previous video on data types, there is a class called list that instantiates objects of type list. So we can, for example, take the latest iteration of my list, which is empty right now, and we can append. That's the method, that's the function, that's the behavior that tells a list object, hey, I want to add something to you. And my list says, okay, Dave, what would you like to add? And I'm going to add the string hello, because I'm a polite kind of guy. Always be nice to your AI overlords. All right, now we can append other stuff as well. So I'm going to do, this is a classic. This is a very nerdy thing. So if you're not familiar with Hello World, don't worry about it. But you can always Google it if you're interested. And then I can print my list. And if I run this, you can see that my list now contains two things, this string and this string. It shouldn't be surprising that if we can add stuff to a list, we can also remove stuff from a list. So lists are mutable. You can remove data. MyList.remove, which is nice. I love it when a method on an object, a behavior on an object, makes intuitive sense. And I can say remove the object, which happens to be the string of hello. And then, of course, I can print my list to prove to you that, in fact, now the list is an item of 1. All right, next up. When you're removing stuff from a list, you need to make sure that you're cognizant of the fact that just because you try to remove something from the list doesn't mean that it's actually going to work. Because you might have a bug in your code or something unexpected happens. So one of the things that you're going to want to do is watch for removal errors. So we have mylist.remove. Hello. And if I run this, not surprisingly, I get an error. I get what's known as an exception that is reported by Python and says, hey, Dave, what are you doing here? You're trying to remove hello from my list when in fact you can't do that. So let's create a brand new list here. New list to access. So we're going to call it new list, and it's going to be a list, and it's going to just have numbers in it because why not? Actually, let's do, 1, 2, 3, 4, 5. So if I can create this list, I can do things like this. I can say, hey, what is the first element of my list? Python starts counting from 0. This is super important. So 0 returns me back the first element in the list, which is the number 1. Not surprisingly, I can also do something like this. Let's go ahead and wrap this in a print just to make sure that it works just fine here. And if I wanted to print the third number in the list, I would actually say new list 2, because remember, we count from 0. So 0, 1, 2. 2 is the third element of the list, and you can see here that it pulls stuff out. So this is just a real quick introduction to lists, just the bare minimum that you need to get started. As you write more and more code with Python, especially in the data science and analytics space, you'll get exposed to more and more functionality around lists, but this is enough for right now to get you started. Now that we're done with this, don't forget to save your notebook by clicking the little save icon here, and then shutting down the notebook, and then shutting down the Jupyter Notebook server. Once again, if you need instructions on how to do that, see the previous video in the series. When you're ready to take your Python skills to the next level with analytics and data science, be sure to check out my free crash courses. You can see here at the time of this recording, I have 4 crash courses available. Free, on demand, one on logistic regression, one on decision trees, one on tuning decision trees. These 2 really should be watched together because you need both to actually build a useful decision tree model, and then one on cluster analysis. If you're interested in learning more about these, there are links below the video in the description. Next up in the series, we're going to talk about Python dictionaries. And when that video is ready, what you should see on your screen is a tile that will allow you to click on it and then take you to the next video in the series. So if you like what you've been seeing so far, please give the video a like. If you want to make sure you get access to the videos, get alerted about the new videos, subscribe to the channel. And lastly, if you know somebody that might benefit from this, friends, family, colleagues, that sort of thing, please recommend the series to them. All right, that's it for this time. Stay healthy and happy data sleuthing.